Hi everybody, we're going to start our next section, algebra, and you don't have to be worried about that word algebra because we're going to take it slow and easy, and if you watch the videos, it's going to help you out tremendously. So let's get on with it, and let's look at this number machine. In front of you, you have a number machine with an input and an output, and that's how a lot of things work in the world. There's always input and output. So let's see if we can figure out how this number machine works. Let's get going. The first number to enter the number machine is 2. It's going to go into the number machine, and our output is going to be 5. So let's mark that down. Input 2, output 5. Okay, the next number going into the number machine is a 5. It's going to go into the number machine, and when it comes out, it becomes an 8. And the final number of the number machine, a 12 goes in, and let's see what's going to come out. 15. Okay, can you guys figure out what the number machine trick is? How did we get from the input to the output? If you want to, you can pause, or you might be thinking about it right now. I'm going to look and say, how did I get from 2 to 5, 5 to 8, and 12 to 15? And I can see that each time there's a pattern there, and the number machine is going to tell me that I added 3 each time. So that is the rule for this number machine. Okay, let's check out the next one. This one's pretty cool. The number machine, we called them X and Y this time. Last time they were the input and the output, but X and Y is the same exact thing as input output. So think of it like that. Okay, first number going in the number machine, we have a 4 going in. And let's see what that 4 turns into. 4 is going to go in, and it turns into a -8. Second number going in the number machine is a 6. A 6 goes in, and let's see what a 6 turns into. -12. All right, and let's see if you can guess this one. A 9 is going to go in the number machine. What is a 9 going to turn into based on what's already happened? It's going to turn into -18. So you guys, can you figure out what's going on? How do we get from 4 to -8, 6 to -12, and 9 to -18? Think about it. And I'm going to say that you're going to be multiplying by -2. That is the rule for this number machine, the second one. All right. And let's check out the final number machine. We got some new words here, domain and range. Well, don't be scared because we called them input output before. We also called them XY, but we have another name for them called domain and range. All right, so let's check out what's going in this number machine. He's saying, wait a second, is this even a math trick? These are so easy. A 3, Mr. Babiak, what's a 3 going to turn into? Well, a 3 is going to turn into a 3. Is that right? Let's find out. A 4 is going to turn into a 4? No, 4 is going to turn into a 5. So what's going on with this number machine? It's a little weird, right? A 7 is going to go in the number machine. And what is a 7 going to turn into? See if you can figure this one out. If you want to hit pause, you can. But I'm going to go on with a trick. A 7's going to turn into an 11. So think about it. How do you go from 3 to 3, 4 to 5, and 7 to 11? And here's your hint. Sometimes you can use a combination of adding, subtracting, multiplying, and dividing. All right, and I'm going to tell you what it is. You are multiplying by 2 and subtracting 3 every single time. So think about that. 3 times 2 is 6, minus 3 takes you back to 3. 4 times 2 is 8, minus 3 is 5. And finally, 7 times 2 is 14, minus 3 is 11. So that is the rule for this number machine. And that's a lot of what algebra is. There's input, there's output. And you can call them a lot of different things. You can call them XY. You can call them their domain and range. A lot of names. There's a lot of names for those things. All right, so let's look. You can look at these things a lot of different ways, like we said. But let's take a 2 turned into a 5, a 5 turned into an 8, and a 12 turned into a 15. That's how we started. And we can represent that with arrows, like in the problem right there. It could also be represented as an ordered pair. All right, you have your x's and your y's. So this would be your x, this would be your y, x, y, x, y. And you could also represent it in a graph. And you can see when we graph it, the pattern was adding 3 every time. And if there's a pattern over here in this section, it's weird because there's going to be a pattern over here, and you can kind of see it makes a straight line. And in math, in algebra, we call those linear, okay, which we're going to be even talking about later. So let's look at the second example that we talked about. We've got all those different names for those things. And remember, a 9, 8, 6, 18, 4, 12. I don't remember that, but it can be out of order. Remember that the pattern was multiplying by 2. So the 6 actually went with the 12, the 9 went with the 18, and the 4 went with the 8. So although they're out of order up in this section up here, we can show what order they're in by connecting them with arrows. And when we write the ordered pairs, again, it makes sense, okay? We are multiplying by 2, multiplying by 2, multiplying by 2. And when we graph it again, you can see that, hey, wait a second, it looks like there's a pattern here. And it makes it linear. So a lot of times when we have a pattern over here, we're going to get a line over here. Okay, and let's look at the final example. We had a 3 turn into a 3. This is a weird problem, right? A 4 turn into a 5, and we had a 7 turn into 11. And you can write them as ordered pairs. You can graph them, and again, we found a pattern over in this section. It was multiplying by 2 and subtracting 3. And since there was a pattern over there, the pattern over here is linear as well, which is pretty neat. Okay, so let's go on to the next section. The vocab that you just learned. You learned domain is the x value or the input. You learned that the range is the y value or the output. And 2 new words. This is the one, a relation. Think about having a relationship with somebody. It takes more than one person to have a relationship. So it's a set, not just one ordered pair. As long as you have more than one ordered pair, it's called a relation. All right, and for the biggest word that we have, it's a function, okay? Whoa, a function is where each domain has exactly one range, or in other words, each x has exactly one y, okay? And that kind of might be confusing, so let's go over some examples. Let's look. Is the relation a function? So basically, are these ordered pairs here functions? And you always have to think about this. Does each domain have exactly one range? So let's look at this 9. Does this 9 have exactly one range? Or in other words, does it have one arrow coming off it? And the answer is yes. Does this 6 have one arrow coming off it? Yes. And does this 4 have one arrow coming off it? And the answer is yes. So all these domains have exactly one range. So that is a yes. All right, let's look at the next one. Does this 2 have exactly one range? Yes. Does this 5 have exactly one? Yes. And does this 12 have exactly one? Yes. And if you're paying attention, you might have saw the sneak preview of what this guy's going to be. But let's check it out. Does this 4 have exactly one range? Basically, with this number machine, is it possible that I could turn a 4 into a 3, and then using the same number machine with the same trick, could I turn a 4 into a 5? And the answer is no. Okay, that's what makes it not a function. It's impossible to turn a 4 into a 3 and a 4 into a 5 using the same number machine. All right, so that would be a no. Let's look at the last one. It's a little tricky. Is it possible that I could turn a 7 into a 7, a -2 into a 2, and a 2 into a 2? Is that a function? Well, let's think about what the definition is. Do these domains have exactly one range? Does that have one line coming off it? Yes. Does this have one line coming off it? Yes. And does this have one line like, whoo, what about a tongue twister? Does this have one line coming off it? And the answer is yes. So even though that they share one range, you're wondering, is that possible? And yeah, the rule here is actually, if you thought about it, if you take the absolute value of 7, what do you get? 7. If you take the absolute value of -2, you get 2. And if you take the absolute value of 2, you get 2 also. So that is possible. That is a yes. That is a function. Each domain has exactly one range. All right, that's a lot of new vocab, but hopefully you're getting the hang of it. All right, let's check out this one. There's another way to tell if a relation's a function. You could graph them. And this is called the vertical line test. And a vertical line, just as a reminder, goes straight up and down. All right, I also like to call it the beep test. So you're going to beep with me at home very slowly, and if you see any place where 2 dots are going to hit the line at the same time, we're going to speed up our beeping. All right, so let's do it. The beep test, or the vertical line test. Beep, 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 beep. Well, that beep test wasn't very interesting at all. That passed the vertical line test. There's no place where two dots hit the line at the same exact time. So it passed. That is a function. All right, so let's look at this guy. Does this one pass the vertical line test? Maybe this will be more exciting. Okay, so start your beeping at home with me. And if we get two places that cross at the same exact time, we're going to speed up and flatline. So let's see what that looks like. Start beeping. Beep, 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 beep. Yes, that hit two at the same time, so that means that it is not a function, it failed. All right, so that's how you do the vertical line test. You graph them, you pass a vertical line over them, and if two touch at the same time, right here, that is not a function. Okay? All right, and here we go. Let's look at some example problems, maybe a problem that you might see in your work this week. It says list the members of the domain and members of the range, and they're going to give you a bunch of ordered pairs. So it's pretty easy. All you got to do is look at them and say, my domains, well, my domains are my x's, right? So every place where you see your x, this is a domain, this is a domain, this is a domain, this is a domain. And your ranges, this is your range, this is your range, this is your range, and this is your range. Okay? Is the relation a function? Well, there's a lot of ways to tell, but this is you can do it with this graphing method using a chart, the t-chart. So I'm just going to list all my domains. I like to list them in order, 3, 5, and 7, and we have 2 3s it looks like, but I'm only going to list it once. The ranges, I'm going to list those in order. I got 3, 5, 9, and 11. Okay, so let's see. The 3 and the 5. The 3 belongs with the 5, so I'm going to draw a line from the 3 to the 5. The 7 belongs with the 3. I'm going to draw a line from the 7 to the 3. The 5 belongs with the 9. And the 3 belongs with the 11. And you can see the problem already. See how this 3 right here has 2 ranges? I can't turn a 3 into a 5 and turn a 3 into 11 using the same number machine. It's impossible. So that would be a no. All right, the second way to test it is actually use graph paper. So there's 2 pieces of graph paper that were given with you, and you can print it as many times as you want, but you could use the vertical line test to make sure something's a function as well. So here we go. We got our vertical line. We're going to do the beep test and see if this passes yes or no. Start beeping. Beep, 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 beep. It just failed because 2 of the dots hit the line at the same time. Okay, so that is not a function. It's impossible. Okay, so the next hardest part of this section is the word problems. All right, the word problems, you're going to have ones that are written one way and then they're written kind of backwards. So let's take a look. Take a look. Is age a function of height? And is height a function of age? Well, what does that mean? All right, I like to think about it like this. What comes first? It's kind of like the chicken or the egg. In this case, it's the egg. We always take whatever comes last, and we call that the x value, or that is the domain. And whatever comes first is the y value, or the range. Okay, so we set them up like this. X goes to the left, the height, and age goes over here in the y spot. Just as this is backwards, age comes last, that's x, and height comes first, which is y. All right, just remember whatever comes last is x. All right, so now we're going to think of an example. Let's say that you're 5 foot tall. Could you be 5 foot tall, I don't know, at age 10? And I'm just going to put some ages over here, and I'm going to think, is this possible? Could I be 5 foot tall at age 10, 5 foot tall at age 11, 5 foot tall at age 12? Is that possible? Yeah, at some point you're going to stop growing and you're going to be the same height for a very long time until maybe you get very old and start shrinking. Okay, so this would be a no. This does not look like it's a function because each domain has not exactly one range. There's a lot of ranges, right? So now let's think about the backwards. Let's say that you're 10 years old and you are 5 foot tall. All right, well, if you're 10 years old and 5 foot tall, what happens if you stayed 5 foot tall? And you're 11 years old? and you're 12 years old and you're 13 years old. Is that possible? You say, well, Mr. Babiak, what happens when if I'm 10 years old and I'm 5 foot and I don't know, it becomes 6 and 7? Well, yeah, I don't think you're going to grow to be 7 feet tall, but um, it's possible. But are you ever going to be two different heights? This is the question I have to ask you. Are you ever going to be two different heights at the same age? And you might say, yeah, when I was 10 years old, I was a lot of different heights. But you think about age, you're never really the same age for the same amount of time. You're always 10 years old in 1 second, 10 years old in 2 seconds, 10 years old in 3 seconds. So your age is constantly increasing. Every second, every millisecond, it's going up and it's increasing. And that means that, you'll never be the same height for two different ages. You'll never be the same age for two different heights. Height for age, yes. Okay, so yes, this is a function. Sorry I confused you there. So that's how it works. It can be a little tricky. Just remember that x goes in the thing that comes second is the x. The one that comes first is the y. And if you got any questions throughout the week, please let me know, because this is all new. It's confusing, but please don't think of the subject algebra and say, I can't do it. This is tough. It's a tough word. I've never heard about this. It's completely different, but that doesn't mean it has to be hard. Take your time, ask questions, and if you're struggling, make sure that you talk to me through chat or email. All right, so hope you guys have a great week, and this is the basis of where it all starts. Okay, so pay attention and we'll get you where you need to be. Good luck, guys.